In this demo, I'm going to be showing you how to run a two-way repeated measures ANOVA or Factorial repeated measures ANOVA. Same example we talked about in the lab. So we have a bunch of college students who have social anxiety, and we want to measure the effectiveness of CBT in two different locations. So we have class and dining hall condition, and then we want to test whether the duration of how long you've been on CBT makes a difference. So no CBT represented as 0, 2 weeks of CBT is 2, 4 weeks, and then 6 weeks. So we see a bunch of different conditions here. Before we want to run our analysis, we want to be thinking about what kind of contrast we're running. So it depends on what kind of question you're asking. For this example, I am interested in knowing exactly where, at what point, after how much duration CBT is effective in my group of participants. So I want to compare pre-test, so 0, with 2 weeks of CBT, and then that 2 weeks, 4 weeks of CBT, and so on. So in that case, the contrast that I should be running is a repeated contrast. So now that I know what I want to run, I'm going to go to Analyze, General Linear Model, and Repeated Measures. And here I'm going to enter both my factors. So first one could be, time, which has 4 different levels. And then we also have location, which has 2 levels. So we add and hit define. Now here, as I said in class, we need to be careful about how we are entering these variables into this box. Because we have 2 variables, so the first column of numbers represent levels of time, and the second one represent location. So the first one that we have is 0 weeks, which is our level 1 for time, and then class location, which is level 1 for location. So we want to enter it first, right? And then we have our 0 weeks and dining hall, which is 1 and 2. So this is how you basically make sure that you are picking the correct order before you enter. So the way they are entered in the data in SPSS right now are in the order that we want SPSS to code them. So I'm just going to copy and put them in this box. Just make sure wherever you see class, it should be 1 on the second number. So just making sure that that's what it is. With zeros, we want the first digit in this pair to be 1, right? So once I know this is entered correctly, I'm going to go to contrast and specify contrast for time variable, because location, it doesn't matter, we only have 2 levels, and no matter what kind of contrast we're running, it's just going to be comparing both of those. So for time, since I want it repeated, that's what I'm going to select from this and hit change. Continue. And in this example, we do need plots. So you could enter these factors any combination you want. You could put location first or time first. It's just going to give you, it's going to plot both of these on a chart, and you can hit add and then continue. Not interested in post hoc still, because we don't have a between subjects factor. This is something that we will talk about in the next lab. No post hoc either. One of the things that we want to do is we want to select from options. So here we are going to be interested in all of these means. So we are selecting all of that. These will help us in understanding exactly where the differences lie, looking at their mean values. So we hit that. We want to compare main effects and do Bonferroni adjustment for post hoc analysis. Descriptives, estimates of effect size. This is what's going to give us the partial eta square, which is our effect size values. And you would need that later on when I ask you to report effect sizes in our homeworks. Transformation matrix, if you're interested in that, ones and zeros table that you use to make in your Stats 1 course, you can do that, and basically that's all you need. So we'll hit continue and hit OK. All right, So it is giving us a whole bunch of tables this time, right? So I'll walk you through one by one, and with a detailed description of how to write an interpretation, you can refer to my detailed lab notes. So just starting off on top, it's just giving you how everything is coded, just a snapshot of the data itself. Not going to get into multivariate tests, but we have to look at the Markowitz test of sphericity. In this case, nothing is significant, which means that our data doesn't, sphericity is fine with this data. It doesn't violate that assumption. So for the test of within subject's effect, we are going to read from the row that says sphericity assumed. So for time, which is 4 different levels we were comparing, we see that it comes out to be significant, which means that there is some difference in levels that we're studying and analyzing, and there is some difference that is somewhere. So the main effect of time is significant, so you would report these statistics, overall statistics. We also see that for location, that is also significant, which again tells us that there is a significant difference in the anxiety level when you talk about classroom versus dining hall. So you report that. For time and location, which is the interaction between the two, this is also significant. So it means that anxiety level in different conditions of time basically depend on the location, or vice versa. So that's how you will look at it. But basically how you're writing interpretation is you're starting off with the overall statistics, whether they're significant or not. And if it is significant, you would go in and look into the test of within subject contrast. So if you look at the simplest one, which was the location, so that is the easiest one to write because it has only 2 variables and 2 levels within it. So it is significant, but when we look at the mean values, so we'll have to scroll all the way down to estimated marginal means, but into the subsection which talks about location. Oops, did I miss it? There we go. So if you look at the mean values here, we see that location 2, which was our dining hall, anxiety level is actually higher. So overall, there is a significant difference, and when students were in a dining hall, they were more anxious, and that is when we are averaging across different duration or different times for CBT. Going back, if you look at the time values, we see that in all of the comparisons that we ran, 2 of those came out to be significant, so which means that level 1 and level 2 is not significant. So someone who had a 0, no CBT versus someone who had 2 weeks of CBT, it doesn't really make a difference in terms of their anxiety levels. But when they had a little bit more of CBT, that is, they go from level 2 to 3, which is from 2 weeks to 4 weeks, we see that something is going on. So there is a significant difference. Now, what is that difference? Which level is higher versus lower? We'll have to go to the mean table. So we'll go to, again, estimated marginal mean section, and we'll look at time. So if you remember, 1 and 2 didn't show any difference, but 2 and 3 did. So if you compare the values for 2 and 3, we see that there is lower social anxiety at level 3, which is lower social anxiety with 4 weeks of treatment as opposed to 2. So there is significant difference in the anxiety scores when someone is on 4 weeks of treatment versus 2. So we'll report that as well. Same goes for 3 and 4, so you would talk about that in the similar way. And if you look at the means again, we see that with 4 weeks, not 4 weeks, with 6 weeks of CBT, there is a little bit more decrease in the social anxiety. And again, if 1, 2, 3, 4 is confusing to you, you can always go in and you can type in exactly what those levels are. So 2 weeks, 4 weeks, and 6 weeks. So this makes it a little bit easier. All right. So the last one is the time and location, and we see that there is a significant interaction only between level 2 and level 3. Again, level 2 was 2 weeks and level 3 was 6 weeks. So again, you can also go in there and change these so it's easier for you to understand, but either way, you can see that's between level 2 and 3. So for us to be able to understand and interpret that, what we're going to do is we can look at the chart here that we plotted. And you see level 2 and 3 are right here, and you can see that these lines here are crossing, so kind of like give us the idea that this is where the interaction is happening. So the blue line represents location 1, which is classroom, and the green line represents dining hall. So we see that for location that is class, it is a higher decrease. There's, the social anxiety level goes way down from 2 to 3 level as opposed to dining hall. So basically this is what you're talking about in the interpretation. So you can read the details in the lab notes. Basically what it's telling us is that when students are in a classroom setting and there is a significant difference in their anxiety level, especially their anxiety level is decreasing a lot more with 4 weeks of treatment as opposed to 2 weeks of treatment. However, when they are in a dining room setting, there is a lesser decrease in social anxiety from 2 weeks to a 4 week of treatment. So basically, this is what it is telling us. And then you can, if reading a graph is something that you don't prefer, you can look at the mean values on top of that, and this is basically going to tell you the same idea. And we talked about plotting that information in kind of like a flow chart, you can say, and you can refer to those notes in terms of how we're doing that. So basically, this is it. I'm not going to get into a lot other details for now because I think this is sufficient for this lab, but we'll get into a little bit more specifically talking about post hoc comparisons or pairwise comparisons maybe in the next lab. So I think this is all you need, and hope this is helpful. So again, this was demo for our two-way repeated measures ANOVA or factorial repeated measures ANOVA. Thank you.